If you've watched the videos, Mr. McFarland did show both of these formulas, and so we're going to apply it right now as we look at number one. A sum of $4,000 is invested. That is what your investment goes to. This is your initial investment. So I'm going to write down $4,000. By the way, I'm going to not put down a comma. Sometimes I see people putting a comma when they write it down, and then when they plug it into the calculator, they get confused and they change that comma into a decimal. So $4,000 is invested. We have an annual rate of 6%. When I plug that in, 6% must be written as a decimal. I'm taking the decimal and I'm moving it two places. The decimal is after the 6. I'm moving it two places to the left to put it into decimal form. The number on the bottom, called the n, is going to be the number of times it's compounded. So in 1 year, there's 12 months in 1 year. 12 goes on the bottom. Up above, the n again is 12. There's 12 months in a year. T is the number of years the investment stays in there. It's going to stay in for 5 years. Now, if we calculate this, we'll know at this rate how much money can be in this account after 5 years. We start with 4,000. I'm always going to do this part first. So I'm going to plug this in. Please do the same with me, even if you've done this before. 1 plus 0.06 divided by 12. I'm going to press enter. And now I'm going to raise this to the power of 12 times 5. That's this portion. And now I'm going to take it times the 4,000 out front. So this is how much money we have. We are going to round this to the nearest cent. So we have $5,395.40. Now let me change this up. I'm going to have you turn to your partner. If I said to you, in those 5 years, how much interest was gained in 5 years in this account if no additional money was entered? You have 30 seconds with your partner. In order to figure this out, I'm going to take my calculator, I'm going to take this amount, and I'm going to subtract 4,000. So in the span of the 5 years, if no additional money was added, $1,395.40 was gained simply in. Okay, so let's look at number 5 right now. Number 5 is a continuously compounded account, has this amount of money, but it's invested at this percentage for 6 months. How much money is in the account at the end of the 6 months? I want you to do me a favor here. I want you to underline 6 months. Now, when we do T in terms of time, it's in terms of years. So how could I write 6 months as a value in terms of years? 6 over 12, which is 1/2, right? So I could write 6 over 12, I could write 1/2, I could write 0.5. They are all equivalent values. I would like you to write, oh, sorry, I meant to write 0.5, or you could put 1/2 or 6 over 12. They're all equivalent. The next thing is I'd like you to circle continuously compounding. So instead of it compounding every quarter, which is 4 times a year, or every month, which is 12 times a year, or the number of days in a year, 365 daily, it's continuously compounding. And in this video, if I remember right from last year, does he have you use 9 4 times, 9999, something like that? So let's figure out if we have this here. All right, so we have continuously compounding. He has this much invested. So let's write down 1,800. We have a rate. I'm going to change it into decimal form. And now it's continuously compounding. When you see continuously compounding, we're going to use the word 9 for the number 9 4 times. And then we'll get all the same decimal amount. Because it actually, just real quickly, it's going to hit an asymptote, and that's why, yes. Well, let's see if we get the exact same one. Maybe we do. Let me see if we get the exact same. So do you guys have an answer down on your paper? Okay, let's see if we get the same one. So I'm going to come up here. I'm going to do 9999. I'm going to take it times the number of years, 0.5. See what yours is, and now let's see what mine is. So I'm going to go 1 plus 0.0254 divided by 9999. And then I'm going to raise it to the 9999 times 0.5. And then I'm going to take it times 1,800. And this is what I get. Now let's check. Maybe I'm wrong. That is the exact same answer he has. 1823. You could do me a favor right now. I like the feedback. Plug it into this one. I haven't watched his videos in over a year. Plug it into this one. Do you think it's the exact same thing? Is he suggesting this is the one you use when you talk about continuous compounding? Okay. Well, let's try another continuous compounding because I love this to see if we can use either one. Does that make sense to you guys? So let's go right now down to, can everybody show me another continuous? Let's go up to number 3. Go up to number 3. Okay, so the final balance is going to be 6,000. I need to use another piece of paper here to show my work. The final balance is going to be 6,000. I want to know what is this initial balance. And I know that we have a rate of 6%. It has to be written as a decimal. And it's going to be compounded continuously. I'm going to put 9 down 4 times. And it's going to go for 10 years. 9,999 times, 10 years. So I'm going to show you really quickly how I'm going to solve this. Everybody's looking up here. I have 6,000 times or equals P times whatever this value is. And I'm going to write that value down as just a number symbol. If I want to isolate the P, that's the principal amount that you invested. To isolate the P, I'm going to divide by this number, whatever that number is. And then everybody can see P's by itself, correct? Let's just see. Maybe this is the harder way. Maybe I should go up here because this is the easier way. Let's just check. So I'm going to plug this in first. I'm going to take 1 plus 0.06 divided by 9999 raised to the 9999 times 10. Okay, this is this number, and I'm not going to write it down because I don't want to adjust this by rounding, and then I have to round my final answer again. If you round more than once, your final answer again is not going to be as accurate. Now I'm going to take 6,000, and I want to divide by this exact same number, and this is what I get. And let's check to see what is his answer.
You forgot 1 9 in the exponent.
Oh no, let's try one more time. 1 plus 0.06 divided by 9999. Do I write it down correctly there? Raised to the 9999 times 10. Got it? And then I'm taking 6,000. I'm dividing it by that amount. And this is what I come up with. And that is the exact same answer that he has. Does everybody see that? So what I'm hearing us say is that if we just choose to use this formula the entire time, when we see continuous, we're going to have this n value be 9 about 4 times. What it does is it goes to a positive infinity. It has an asymptote. Or you can choose to use this. But here's the deal. When it comes to our test, on the actual unit test, this is going to be on the unit test. When it comes to our AP exam, we have to have these memorized. Okay? So either one of these will work for continuous. Thanks for pointing that out for me, Allison. If you use this for continuous, we're going to put down a 9 4 times. All right, I want to see this on the board. Are you guys ready? Showing all of your work on the board, whether you have this done or not. We're going to jump around here. I want to go to number 2. On your board, I'm going to press pause on this video. In my 0 hour, if you're watching this, I'm going to demonstrate both ways right now. And I agree this is probably easier. As a student, I may just memorize one. They will be provided on your test, but I think this may be easier to plug in. Let's check and see at this time. So I have 7 years. So I'm going to do 1 plus, we have a rate of 0.065. It's going to be continuous. So I'm going to do 9 4 times, raised to the 999 times the number of years, which is 7. And then we want to know how much money will be in the account. So I want to know the end value when I am going to initially invest 500. So I'm going to first do this portion right here. So 1 plus 0.065 divided by 9999 raised to 9999 times the number of years. Taking that times 500, I come up with 788, and we're going to round to the nearest cent, so that's to the nearest hundredth, 0.09. So 788.09. And it's okay if you chose to use this method. It probably is faster. How many were able to achieve this one using this formula? Hands up high in this class if you chose to use this formula. Okay, let's try this one. So I'm going to invest 500. And then I have E, which is Euler's number. And I'm going to raise it to a rate of 0.065 times the number of years. Let's make sure we get the exact same thing. So I'm going to first do the E portion, 0.065, and times 7, take in times 500. Boy, that seems like a lot less work. Again, I think the only advantage, that seemed like a lot less work. I think the only advantage to doing this is I'm only memorizing one formula. But this definitely seems simpler when we're working with continuous. Now let's jump down, for time purposes, let's just jump down to some of the harder problems. I want us to look at 11, 12, and 13 through 16. So, is everybody ready for 11? I believe that my method may definitely be a lot harder. Can you put your pencils or pens down, please, and just watch me do number 11? I definitely think that the method I'm going to use, based on the fact that I'm using the first formula, it may be a little more work. So here's my formula. It's A equals the final amount equals the principal. And okay, it says, how much money should you invest in a continuously compounded? So I'm underlining continuously compounded. I know these two are going to be 99999 4 times. I know the rate. I've taken care of that. I know the number of years. Now, what I need to do is we need to earn interest. Sorry, we need to earn a total of $1,000 in interest. So if this is 1,000, my final amount is 2,000. If I initially invest 5,000, then my final amount is 6,000. It has to be 1,000 more. Whatever my principal is, my final amount is going to be my principal plus 1,000 more, because this accounts for the interest. It's your principal plus the additional money you earn when it remains in that account. Okay, I'm going to be really lazy here. This amount right here, when I calculate all of this, I'm just going to use a number symbol right now. So I have P plus 1,000 equals P times whatever value that gets me, because I have a number for the rate, for continuously compounding, and for how long this will remain into the account, which was for this problem 5 years. Okay, now if I want to solve for P, let's move P's to the same side. I'm going to move this to the opposite side. So I'm going to subtract P with whatever that value is. I have nothing left over here. Now I have P plus P times that number plus 1,000. I'm going to subtract 1,000 to the other side. This is not hard math. It's just a little messy. And now, does everybody see how there's a P in both of these quantities? So if I factor out a P, what would go inside of here? So that when I distribute, I come up with this. What would be the first one? 1 plus that number sign. Now, if I want to isolate the P, because that's my whole goal, is how much should I invest so that in the end, for this particular problem, I end up with $1,000 extra of interest. If I want to isolate the P, I need to move this to the other side. I'm going to move it by dividing. So I'm going to divide by 1 plus number sign, divide by 1 plus number sign. Okay, I've isolated for P. Now, can everybody grab the calculator with me? I'm going to first figure out what this number sign is, and I'm going to take 1 plus that number. And then I'll take negative 1,000. So you're going to work with me on simply what is this number sign. Number sign is this portion right up here. Okay, are you ready? Here we go. So we are going to do, I'm going to move this up here so everybody can see. I'm going to go 1 plus, we have a rate, transferred into decimal form is 0.04, divided by, okay, it's compounding continuously. There's 3 nines. Now I'm going to raise that to, it's compounded continuously, 4 nines I should have said, times the number of years it remains into the count. This is my number sign. I don't want to write this down, because in doing so, I would have to estimate, or I'd have to round. I don't want to round and then round later. This is my number sign. So now I'm going to add 1 to this on the calculator, so plus 1. And that's this value down here. And now I want to take negative 1,000 divided by this exact value. Negative 1,000. If you have not learned this, we can copy and paste this down. I'm going to zoom this out. We can copy and paste by going divided by, you hit the second key, and you find A and S for answer. And let's see if this matches up with our answer key. Whoa, did I forget to put I did something wrong. Hold on. Can anybody see what I plugged in wrong? I must have hit a wrong key. Can anybody see where this occurred? I worked out all my problems in advance, and this worked. Let me see. Can anybody see where I will look really clearly. Sorry for those that are at home. I know exactly what it was. Here's my mistake. You ready? How did I move this to the other side? But what did I forget to put over here? So what should have been right here? What should have been right here? What should have been here? A negative and a negative. The process was right. The simple algebra at a 7th grade level was wrong, okay? So I'm going to go back here, and I'm going to change this to a negative. So let's go back. Everybody watch. Here, let's try this again. All right, I can speed it up now. So we have 1 plus, we have a rate again. Let's make sure I don't make 2 mistakes in a row of 0.04 divided by continuous. I'm going to raise this to the continuous times the number of years, which is 5. Okay, now we can slow down. I'm going to go 1 subtract this number. 1 subtract. I'm going to copy and paste that exact number. That's the bottom. Now I'm going to take negative 1,000 divided by that exact answer. And now let's match this up. Do we have 4,516 point approximately 66 or 67. Yes, no? Okay. Now, is there an alternative where you use this? Absolutely. You could definitely use this if need be. Okay, you ready? We are going to do a timed competition with your partner. I would like you, if you've already done this problem, to cover up your work so you don't see it and to do it on the board. When I say go, talking the entire time with your partner, you can choose to use either formula because I see the compounded, this is compounded monthly, so we do need to use the first formula. Go ahead right now in number 12. Let's see if you can finish number 12 in 90 seconds. If you're watching this video, please press pause, go through number 12, and I'm not hearing enough talking in groups. I'm seeing a lot of individual actions. Make sure you're working through this, even if you already did it on the board. I'm going to start with this basic formula, A equals P, 1 plus R over N raised to the NT. So I can see here we have a rate of 2.85, written as a decimal is 0.0285. Down below is how many times is it compounded? It's compounded 12 times in a year, and 12 times the number of years, which in this case is just 1 year. It says we want to earn a profit. That means we're going to earn an additional $500 in interest. So whatever the P is, the final amount needs to be 500 more than this. I'm going to write P plus 500 on the left-hand side. And again, I can calculate all of this, and I'm going to be lazy and we're going to call that the number symbol. This is P plus 500. I'm going to move the P's to the left-hand side. So minus, remember that's that small mistake I made in the last problem that made a big difference. I have P subtract P times number sign equals 500. Then I have over here, I'm going to factor out a P to get 1 minus number sign. And notice I had a 500. When I move it over to the other side, it does need to be negative. And now I'm going to divide by 1, subtract number sign, 1, subtract number sign. P is by itself. The rest I can do on a calculator. So I'm going to first figure out what is this number sign equal to. I'm going to come back up here. I'm going to do 1 plus 0.0285 divided by 12. Raise it to the 12 times 1. That's my number sign. And now I'm going to do 1 subtract that value, 1 subtract this value. And now negative 500 divided by the value here that I've been able to when I find the difference. And I come up with, let's see if this matches up with what we have here. I come up with $17,315.87. This would be problem number 12.
At this time, please pause for a moment of silence.